Good morning, ladies and gentlemen, and welcome at our second webinar. My name is Vanessza Hamzók, and I am your host for today's event. Today's topic is sustainability and synergy, where we will explore how innovative bio and recycled solutions with collaborations can drive sustainability in our industry. Our agenda for today includes presentations, short updates about Inno-Comp's developments regarding bio and recycled solutions, a panel discussion about the most important questions in the industry. Furthermore, the experts will answer your questions on the topic of bio and recycled solutions. I would like to invite you to ask your questions via the chat platform. The question and answer part will be fully anonymous, so don't hesitate to ask anything you would like to know. Thank you for joining us today, and let's get started.
Ladies and gentlemen, welcome. Today, I would like to give you a short overview about Inno-Comp's biocomposite family. Biocomposites are materials composed of a polymer matrix and a filler material. These can be classified into three main categories based on the origin of their components. First, we have fossil-based polymers and natural fillers. In this category, the matrix is from fossil resources, but the fillers are natural, often sourced from agricultural or forestry byproducts. Next, we move to bio-based polymers and natural fillers. Here, both matrix and the fillers are from renewable resources. Finally, we have bio-based polymers and mineral fillers. These biocomposites use renewable polymers as the matrix, but incorporate mineral fillers such as talc or calcium carbonate for enhanced properties. Biocomposites can be biodegradable or non-biodegradable from the decomposition point of view. Next, let's focus on our work at Inno-Comp, particularly with polypropylene-based biocomposites. Here, the natural fillers we use include wood fiber, cellulose fiber, ground apricot shell, nutshell, hemp, corn cob. The polymer is polypropylene with different mass flow rates and includes both homopolymer and copolymer types. Benefits of these biocomposites are: incorporating natural fillers can reduce the overall polymer price, can lead to cost reduction. The use of natural fillers increases the biocontent of the composite. These components are lighter, which can be beneficial for different applications. These biocomposites have some weaknesses. Polypropylene is not a biopolymer, which means it doesn't meet some sustainability criteria. To reach consistent coloration can be challenging. Moving on to bio-based polymers-based biocomposites, we use the following fillers: talc, calcium carbonate, wood fiber, cellulose fiber, ground apricot shell. The polymer in this case is polylactic acid, PLA, which we select based on specific application requirements. Let's see what advantages these types of material have. Bio-based composites can have up to 100% bio-based content. These materials are compostable, increasing their environmental appeal. Polylactic acid can replace fossil-based grades like polyethylene, reducing dependence on non-renewable resources. The most important advantage compared to fossil-based plastic is that PLA has significantly reduced carbon footprint, as can be seen in the figures below. These materials have weaknesses too. First, the higher cost, because PLA is generally more expensive than PP. Finding suitable suppliers of PLA and natural fillers is a challenge. PLA has higher density and requires careful drying to manage moisture sensitivity. Finally, let's discuss about the biocomposites at Inno-Comp. We have the so-called CSB family. This is how we differentiated these products from our other compounds. We have a thin screw extruder from Tyson, suitable for production of biocomposites, product development and medium production volumes. Drying systems are basic for reducing moisture content, especially for PLA-based composites. We carry out product development together with customers in order to produce the product that best suits their needs. Here you can see a diagram showing the biocomposites grades sold and our forecasted quantities. This illustrates the growing demand and our commitment to expanding our biocomposites offering. In conclusion, biocomposites represent a promising path toward more sustainable materials, combining the strengths of natural and synthetic components. At Inno-Comp, we are constantly developing and expanding our biocomposites grades. Next topic is the recycling solutions, will be presented by Balázs. Thank you for your kind attention.
Thank you. Today I will be discussing the importance of regranulate consumption in our production process. We employ two distinct approaches to utilizing regranulates. It's the closed loop and an open loop. In a closed loop system, regranulates are sourced from our own production waste. This means we recycle our in-house materials, converting them back into the production to achieve maximum resource efficiency. On the other hand, the open loop system involves regranulates obtained from external sources. These are post-consumer or post-industrial materials collected and reprocessed to create a new product. You can see on the charts, in case of both systems, we increase greatly our consumption year by year. These slides illustrate the communication process between our team when dealing with customer requests and how the sustainable solutions are important, because we created a group named Sustainability Team to engineer the tailor-made solutions only in this field. This allows that both regranulate and virgin polymers requests are effectively managed and integrated into our product development. The project managers, they act as the initial point of contact with customers, and the sustainability team, project managers relay requests related to regranulate-based polymers and the biocomposites requests to this team. Our post-industrial and post-consumer regranulate-based materials serve crucial roles in both the automotive and the household appliance sector. Let me show you a few examples. These products, post-industrial regranulate-based materials for automotive. These products originally based on virgin polymers and are then converted into high-quality recycled polymers. This components process allows that we meet the high requirements of automotive industry for durability and performance. Household sector. In the household sector, we offer different regranulate-based materials tailored to meet different requirements. For example, 40% off-field PP, we successfully developed 3 versions, 50%, 75% and the full of PCR regranulate content. Additionally, we have 20 and 50% off-field PCR materials as well. At the end, you can see 20% glass fiber grades with different PCR contents. We can offer these according to the customer requirements. PCR for the automotive industry. The Inno-Comp group started its own development to find the right PCR contents and types can be used for automotive applications. 30% glass fiber filled PP is targeted. This type has high requirements for the flexural modulus and fogging properties, but the development stage will be finished soon and we will have the possibility to offer these grades for the automotive suppliers. This version demonstrates our commitment to integrate post-consumer regranulates into our products. In conclusion, our strategic use of both post-industrial and post-consumer regranulates in various sectors not only supports sustainability goals, but also boost versatility and functionality of our products. Thank you for your attention, and we are looking forward to the next topic, which is the roundtable discussion with the invited experts.
Thank you. As Balázs mentioned, now is the time to move on to our panel discussion. I'm delighted to welcome our guest speakers, Krzysztof Nowosielski, László Bűdy, and Tamás Tábi, who are honoring us with their presence. Additionally, we would like to welcome Péter Torma, our Managing Director, and István Balogh, Head of Corporate Sales, Project and Marketing.
Ladies and gentlemen, good morning and welcome to the panel discussion of our webinar. My name is István Balogh. I am leading the sales, project and marketing team of the Inno-Comp group, and I will be the moderator of this event. Our aim of today is to talk about the complexity of the sustainability, which is clearly a challenge for all the value chain, and we also all know that this topic will have a major impact on the future of the plastic industry, on us. I expect that our guest will have a different view on how to find solutions, how to make proper maneuver in that labyrinth, because all they are coming from a totally different segments. With this, I would like to ask you to make a short presentation, a short introduction, and I suggest you a kind of clockwise movement. So Tamás, what about starting with you, please?
Thank you very much, and I would like to welcome everyone to this webinar. Let me introduce myself. I'm Dr. Tamás Tábi. I'm a Research and Development Director at Bibo Franchise Ltd, Hungary, and I'm also working as an Associate Professor at Budapest University of Technology and Economics. I acquired my PhD degree in 2011 in the field of development of bioplastics, especially PLA or polylactic acid-based bioplastics. And I continued my research. Now I almost have 100 scientific papers. And about a year ago, I joined Bibo Franchise Ltd as an R&D director, and currently I'm responsible for developing and producing bioplastic parts like reusable and bio-based cutlery, straws, bottles, caps, and waste collector bags, and lots of other products are coming soon. And since these materials are all kind of bioplastic compounds, this is why I'm participating here at the webinar.
Thank you, Tamás. Krzysztof?
Good morning. Thank you for invitation, and thank you on our online visitors for watching us. I'm Krzysztof Nowosielski, and I represent ML Polyolefins. I'm business director in this company. ML Polyolefins is a leading recycling company in Central Europe. We are processing mostly polyolefins, polypropylene. Our total capacity is 25 kilotons per year. We are also managing waste all around Europe. And we have also a small injection molding company where we are processing some part of our products. We are supplying very different sectors with recycled materials. We both process PCR materials and PIR. And we have also the compounding line, which is helping us to develop new recipes based on recycled materials for the market. Thank you.
Thank you very much, Krzysztof. László, the turn is yours.
Welcome everybody who is watching us via internet, and thank you for the invitation as well. So myCEPPI is the leading consulting plastic consulting company in Central Europe. Our client is know us about the most read weekly polymer price report, which contains not only the prime polymer prices, contains recycled prices as well. And our another important services, we are the organizer of the second biggest plastics event in Central Europe after Plaspor, because the Plaspor is the biggest, where the companies who want to buy polymers and those who want to sell different kind of services to the plastic converters can meet one hand. On the other hand, it is developed in this year because that the exhibition part is more significant than before. 5 injection molding machines will shown in working, and of course is very important part of our event, the conference. When we're talking about the recirculation and the actual challenges of the plastics industry, over the recirculation, over the sustainability, I think the main challenge for us now is the economical development, when it's expectable, what is expectable. So I would like to encourage everybody that come and visit us and participate in the discussion, because after this webinar, I think a lot of open question remains.
Super. Thank you very much.
Thank you.
Peter, finally some words about you.
Yeah, let me welcome everybody who is watching us. My name is Peter Torma. I'm the managing director of Inno-Comp Kft. I'm heading this company since the beginning, since 25 years. We are an integrated polypropylene compounder, mainly working on the field of polyolefins, inside polyolefins, polypropylene. And actually we are on a very big turning point with all our activities in this challenging market. And I think this webinar also shows possibilities and barriers for the compounding industry.
Thank you very much. So, before starting the discussion, I would like to come back to Vanessa's message that later we will try to ask the questions, hopefully receiving from you on the line. And that will be also an important part of the discussion. But starting with you, Tamás. So you are definitely for the bio-green stuff.
Right.
So how do you see the competition between the biocomposites, biocompounds, and the mechanical recycling part?
Thank you for the question. Once a professor of mine said that completing and not competing. So I think these two things do not compete, but they complete each other. Of course, mechanical recycling is mostly feasible for ordinary plastics. It's a readily available process to recycle them. But and if people think on bioplastics, and under bioplastics I mean bio-based and also compostable plastics. So if people think on these materials, they often think that these materials can only be composted, but that's not true. They can also be mechanically recycled like ordinary plastics. Of course, we have a degradation, a kind of decrease in the properties during the mechanical recycling, so it cannot be done, cannot be made unlimited times. To make an example, like at us at Bibo Franchise Ltd, we injection mold bio-based and compostable cutleries, and if the injection molding machine makes a scrap part, a bad part with some injection molding errors, we do the shredding and do the reprocessing, or within the plant itself. Or we have products which are sold to the customers, and when they bring back the products, we usually do the shredding and do the recycling. But as I told you, these the recycling process cannot be done unlimited times. So short term it can be done. In long term, I believe more in chemical recycling.
Okay.
When our partners hydrolyze the polymer into monomer and build the polymer chain again. And in this case, there is no decrease in properties. So a chemical recycling can be made unlimited times.
Thank you very much. I appreciate it.
Thank you.
I like the wording competing and not competing. Actually, Krzysztof, as an experienced collector and also processor of both post-industrial and post-consumer waste, which do you think the most important type in the future for the plastic industry?
Well, for the future, so it is a good question. Through the years, we have the situation that post-industrial or PCR, it doesn't have any difference for the processors. But since some time, especially the European legislation is making a bigger pressure and is increasing pressure for using the PCR materials. But I would like to say that we have rather divided the Europe regarding using this kind of materials, because we are the Polish producers, so we are located in Poland, but we are talking here in Hungary. So in our part of Europe, in Central Europe, we don't have so well organized the management waste system, and that causes the problems with waste streams for recycling companies. So we don't have so big possibility to use so many PCR wastes to our production. But in the coming years, I see also the bigger pressure for using the recyclates in total. So the increasing volume and demand which will be for recycled materials will cause the problem that we will rather have not enough the materials in total recycled. So I would like to say that rather there will be not enough the material, so there will be no difference for the processors between the PCR and PIR, and both of them will be very valuable for processors.
Fair enough. Thank you very much. László, so your daily activity, you have tremendous opportunity to talk with different members of the value chain. Based on this, what do you think are the biggest challenges in terms of mechanical recycling that plastic processors face or even will be facing in the next few years?
I think the first and the most important, the majority of the plastic converters has no real picture about what is ahead, what kind of requirements we should fulfill. The first deadline is 2025. Basically, it is concerning for the PET and the single-use packaging. But 2030, it is already very close. It is only 6 years. And when we facing with, in average, in the packaging field, 30% of recycled content in the packaging product, and which is interesting in the for example in the automotive, we should reach. It is not a fixed this number. It is just a medium scenario, 15% and later on 20% in the plastics. Parts of the car should contains this mandatory recyclates content, but the problem is it should be PCR. That I'm so skeptic regarding that. It seems that the target what the European Union is defined, it mostly ideological. It is mostly wishes, because now we are facing now with the problem that in several aspects we couldn't solve the problem. The one of the most important, there is no enough valuable processable waste. That majority of the legislation is coming for the people because they are recognize the problem. There is a lot of plastic rubbish, not waste. We don't mix the two words. It is not waste. It is rubbish, and the rubbishing is made by the people. It is not the problem of the plastics. The making the good quality waste. It is the key challenge now, because Krzysztof know more about that. How difficult to collect 25 kilotons valuable polypropylene plastic waste in Central Europe. I know their activity. They are collecting the polypropylene plastic waste in Bulgaria to Baltics. It is a huge territory, but it is not enough. Not enough for the production. This is the one of the basic problem. Another basic problem, nobody calculated the degradation. You are basically PP compounder, you know better. When you reprocessing, when recycling the polypropylene, it is very easy to see that due to the degradation, that the molecular weight is changing, the MFR is increasing. One of our projects in the Hungarian Plastic Association, we identify 77 different kind of polypropylene application. And nowadays, we find solution, recyclation solution, only 15. Only 15. What about the rest? What about the majority? What about the 80%? So that these problems are not solved in mechanical recycling way. In the chemical recycling, also very problematic because it is a miracle. It seems a miracle. It is a solution for everything. But the fact, we have only 400, not more than 400 kilotons chemical recycling facility in Europe. From that, 200 kilotons is pyrolysis. So that fulfill the requirement of the market, we need 10 million tons pyrolysis oil. According to BASF, which is the biggest chemical company in Europe, according to them, it takes 20 years when we build up these capacities.
Thank you. Thank you for that. Interesting opinion. I will not change this in my role, but okay. Thank you again. Peter, managing a compounding operation, a compounding company, what comes to your mind if somebody is asking you to put recyclate, a kind of waste as you wish, into the recipe of your products, which obviously should go for high-end demanding application?
It's a very good question because partly touched by both presenter of me. Two things, quality and quantity. Quantity because of the point touched by myCEPPI, Mr. Bűdy, and quality again touched by him because with the degradation, we are every recycling performance, we are degrading or worsening the quality of our products. And this gives a lot of challenges for a compounder also. So we have to harmonize the worsening quality of the recyclates with obviously with virgin materials, so it has to be mixed together. And our key role here is that finally our customers are getting a quality which is satisfying their needs, satisfying the needs of the end users. And this can be challenging because our customers got used to colors, many colors. I mean, from white to yellow to red, blue, gray, black. And especially with the PCR content, this coloring will be limited. So I think that's the limit or the barrier which I mentioned in the introduction, which we have to face. But quality-wise, a compounder can do a lot also for the product. So there are surprisingly good results in respect of physical qualities in the products which we are doing now for our customers, and for my biggest surprise also in coloring, so that we can meet some color expectation of our clients. And according to the latest studies, also fogging and VOC issues, which are very, very important for the automotive industry, can be managed through different compounding. What I mean is that we have to be prepared for different handling of raw material, different processes of our compounding lines. Definitely in our investment we have to consider that the degradation of the product is as small as possible in our processes, and also the final handling of the, so to say, ready-made product has to be differently made, which means we have to, reduce the violate content in it. So after compounding, we still have to add another step of I would not say production, but a kind of final preparation of the product. This will require investment from the company, but we are ready to take these challenges.
Thank you for this. A difficult life for us, I would say.
Yes.
Okay. Many thanks, gentlemen. And I think we can move to the second part of the panel discussion. I am checking the chat box, and I can see a few questions popping up. So maybe I start with the first one, and I think it will be for Krzysztof. Will the current PCR sources be able to provide sufficient quantities for the production of sustainable raw materials? If not, this shortage could lead to an increase in the price of granules.
Yes, that's the truth.
Easy question. Yeah.
Short answer. Yeah, definitely we don't have enough waste sources, especially in our part of Europe. So that's why also big corporations from Western Europe are trying to put the hand on the companies which are managing waste in our part of Europe, because there will be a really high value of waste in the coming years. But okay, I see the whole discussion, the temperature is +3 degrees, but we are coming from the different parts of the business. But regarding this, what Peter and László also said, yeah, we all face the same problems regarding the quality, regarding the repeatability, and regarding the needs of the customers. But what is the problem regarding the PCR? The PCR is also not a good waste stream for preparing enough quality material from our point of view as a recycling company. Because let's check it from the end. The final processor, he needs the material which will be repeatable and with the high quality, not only because he wants to have the easier job to do, but also because he got some limits regarding the process that he got. So we need to be able to secure him in enough quality material, and to do it, of course, from our point of view as a recycling company, it's better to process PIR material because it's easier to separate the different kind of this waste.
Super. László, it's your turn. You already touched the mechanical recycling, chemical recycling part. So my question, or the question to you, do you see them as a complementary part, or do you see them they are in competition?
It's a very good question. Why is a good question? Because that theoretically, that's why the decision makers and why the industries prefer the chemical recycling, because that theoretically it is able to process the mixed plastics waste. But I would emphasize theoretically, because that in nowadays, as I mentioned, there's a low capacity in Europe, and are in production. That's because that it is not clear for everybody. That I have some experience in chemical recycling in tires. That I think this example can highlight what is the problem with chemical recycling. Because the chemical recycling, and I think Tamás is no more about that. I'm economist basically, but no more about that. It is a very simple technology. It is a big reactor, and we heating up to the plastics waste to up to 500, 600 Celsius, and then we can get some oil. But I have some experience in the tire chemical recycling, and it was obvious the contamination of the feedstock is a key issue. For example, in the case of the tires, nobody calculate with, because you probably don't know, in Hungary in the middle of the 2000s is built 3 tires chemical recycling plant. Not big capacity, altogether was 15 kilotons. But that it wasn't successful because the tires, after processing chemically, after heating up and window oils, that the oil was very contaminated with silicates, because during the lifetime, the tires is collect a lot of things. And it is true for the plastic waste as well, because theoretically it is true that it is working. As a mechanical recycling is working very well in the laboratory. If we are reprocessing again, it's a little bit changing the melt flow rate and the molecule structure and molecule weight. But nobody calculate with the degradation during the lifetime. Nobody calculate with the contamination. For example, if we put to the pyrolysis plant some plastic cans, which previously contains some chemicals, which is a typicals. Who knows what is resulting these chemicals? What will be the reaction? So that's the problem. So nowadays it seems that in the pyrolysis and the chemical recycling is an experimental phase. We just try to find out how is it working. So that's the biggest problem in the chemical. It is nowadays it is a dream that 400 kilotons is enough for nothing. And back to the pricing of mechanical recycling, because it was an interesting experience for me, because that it's theoretically is true if there is a lack of the mechanical recycled material, it should improve the prices. But why the price didn't go up until now? Because the price is very limited now. It is that not the Krzysztof quality, because Krzysztof quality is the best in Central Europe, but in the average quality what you can buy on the market is the price is between somewhere 800 and 900 euro. But why? Because that, as I mentioned, the recycling companies offering solution only for few application, which is mostly other injection molding products. And this is an oversupply on that field. But another field, there is a significant lack of the material. So that we should think, and everything is coming from the waste collection, the very sophisticated waste collection and waste management.
Thank you for that. Appreciate it. I think we will have two questions coming from the audience, and one to Peter and one to, it's very good distribution. So Peter, I will start with you, and after that we go to Tamás. So to what extent does the use of granulates affect the quality of premium products? What is the effect on product life and safety? Good question.
Yes, it's a very, very good question. Actually, it's depending on the source of the regran. So if we are talking of recycled material from a spunbond film, which was intended for hygienical application, actually, I would say our customer would not even recognize that he's using a recycled-based material. And we could give all the certification regarding lifetime, and even the quality change would be within percentages, according to our experiences, since we are doing such materials. And there is the other extreme. I mean, a PCR material coming from the waste, sold at a very low price level, of course, because it's a mixture of everything. The polypropylene content is hardly 80%, which is a big number. And the rest is, I mean, everything, what you can find in the packaging industry. So there, I must say, even using 5% of such material is reducing the quality by 5 to 6%. If we go to this 15% or 20%, which is intended by the legislation of such material, I would say we are exceeding 10% in quality decrease, and of course we need to put more stabilizers to ensure the lifetime, the requested lifetime of the material, which gives additional headache on other sides. For example, if the customer wants to inject a thin part out of this will give challenges to the end user. To the injection molder. So, but there's, I mean, the two extremes I mentioned, and I'm sure Krzysztof could also tell different PCRs. So there are different PCRs qualities, because we are also working with much better PCRs where a selection is done from the sources. I mean, because don't forget, it's not only the communal waste which we are using, but we are also using the household appliances which are dismantled, the cars which are dismantled. They are I believe, much cleaner streams. And from this, of course, we can produce reliable, good quality, continuously standard materials. And the question is the volume. The availability of this part of the PCR materials. And so, all in all, it's all depending on the raw material, and which gives a challenge to a compounder, the quantity of the source. So if the project is, let's say, for 2,000 tons, and we have to add 20% PCR, that means we have to ensure 400 tons of PCR material for this project, which is relatively continuous in quality and in availability. Because, you know, some products availability, how we understood, is also seasonal from the PCR content. So some materials are just disappearing from time to time over the year from the availability of the PCR's content. So gives us a lot of challenges. Definitely we will have to prepare ourselves logistically also for these things.
Thank you, Peter. So again, a little bit complex.
Yeah,
situation,
everything is complex here.
Okay, thank you. So Tamás is the next one. What are the main application of products, or do you see any limitation of entering different segments?
Thank you very much for the question. Currently, I think bioplastics, so bio-based and compostable plastics, the application of them are mainly packaging,
Okay.
where it comes in contact with food. And just a quick remark: we've been talking about mechanical recycling, chemical recycling, and it's not always possible to make these recycling processes unlimited times. But I think composting of bioplastics is a good solution when the material has already degraded mechanically and chemically to a certain level where it cannot be used to reprocess it to make a product. But back to the question again. Sorry, what was the second part of the?
Do you see a limitation to entering new segments?
Yes. Let's start with some interesting facts about truly entering new sectors. Every 3 years there is a K show at Düsseldorf, a plastic show, Kunststoffe show, and typically I see very interesting and new products and new applications, bioplastics arrived too. And what are these applications? I've seen housing of a monitor and a mouse, so electronic devices made from bioplastics.
Okay.
And also seen...
Which is not really packaging.
Which is not packaging. And I also seen automotive parts, not in the interior, but on the not visible parts in the car. It was a filter box made out of bioplastic, so bio-based and compostable plastics. So I think we can do what we want if we do the research, if we add the certain additives, and here comes the limitations. So during the research, we have to modify the base bioplastic material, and we have to increase toughness, durability, so to make it a long life cycle material. But as the examples show us, it can be done. So slow steps, but I'm quite certain that bioplastics will enter more and more applications, not only packaging.
Clear message, thank you. And I was a bit surprised, but okay, that's a good learning also for us. Thank you. We are still a little bit time, fortunately, so I stop now the question and answer panel and would like to raise one common question to all of you. And maybe we can start with Krzysztof. So the question to all of you regarding sustainability and waste processing and biocomposites and mechanical recycling. What is your expectation, forecast, or prediction about the next 5 years in your particular area where you are working and where you are active?
I think regarding the mechanical recycling, the role of this sector will be increasing. Because currently the demand is coming because of legislation. So it's not the pure economical reason why we have demand for this kind of materials or not. Also the prices are depend from the legislation, not from economical issues. And I think, of course, the chemical recycling will be very important in the future, and I predict that will be the future of recycling. But we have partially this discussion with László at the morning when because we came here with in one car. So for the chemical recycling is still just the beginning, just the beginning of the process, because currently we are talking about 250 tons of capacity totally. It's around that. It's not typical chemical. Yeah. So there are some corporations which want to increase for even higher volume of recycled materials in their use than the total capacity that we have in Europe currently for this kind of recycling. So definitely the mechanical recycling will have the leading role in the coming 5 years.
Okay, so you will have still enough time and things to do. Thank you very much.
But for what enough time? I don't think that we will compete with chemical recycling, and I think those two sectors will be rather complementary. Not rather will be symbiosis than competition, in my opinion.
Thank you very much, Krzysztof. I am really interested in your opinion, but let's move away. Thank you.
So the biggest challenge is balance in the supply and demand. So that I think that there is a wrong assumption from the plastic converter side. They thought that if somebody made legislation offering a solution as well, now is divided. The legislation maker to the decision maker is made something, a decision, but the industry should solve. But the industry is not ready to solve this problem. I think it is an illusion, majority of the plastic converters have, that there will be the material what they can buy from the traditional sources, which will be the rare content. It will not be. So that I think it's not a solution that everybody is purchasing independently some recycled materials. I think in the next 5-6 years, that will over-evaluate and improving the role of those companies who can offering solution for the average plastic converter. What does it mean? Offering repeatable quantity, for example, virgin recycling rates. I think this is the middle-term future when the chemical recycling is reach a certain level, which, as I mentioned, it could be takes 20 years as well. So that I think in the decision maker side, there is another proposal, the administrative solution. It's called a mass balance approach, but for that is also need the significant chemical recycling company. I think the biggest problem will be the struggling, the lack of the material in certain segments.
Thank you. And I think, if you don't mind, I would give the floor to you, and Peter will be the last one. So, Tamás, if we can hear your opinion, would appreciate.
So upcoming next 5 years, I think we at the Bibo franchise Ltd, we are developing, let me say, circular bioplastics. And what I mean is that on one hand, we would like to increase the durability of bioplastics, make it tough, make it high heat resistant, make it mechanically recyclable. During recycling, it should lose as low percent of properties as possible, should be easily chemically recycled, and on the other hand, it should be not only industrially compostable, but maybe home compostable or even soil degradable, meaning you can bury it into the soil and it will degrade by itself. That's our goal. To make these two main properties at the same time. So have a long service time, bio-based plastic, which is tough, and on the other hand, maybe we can even decentralize the composting of bioplastics, meaning if you buy some food and it has a bioplastic packaging, take home the food, eat the food, and then what to do with the bioplastic packaging, which is already contaminated with food. So it cannot be recycled because you have to wash it, you have to send it back to the polymer processing facility. No, you can deal your own waste at home. At least we are developing these kind of materials by home composting. So that is our dream, to make these two properties. And currently I call these bioplastics circular bioplastics, and I hope we will achieve this level.
Oh, thank you very much. Ambition and challenging targets, but I can feel the enthusiasm behind the skin. Thank you. So, Peter, if you can close this round.
Yes, and for us, I believe the biggest challenge will be the variety of raw materials which we have to use in the future. And starting from there, because so far, the availability of virgin material was, with a little bit of exaggeration, limitless. Now we have to deal with different qualities and limitations on availability. And certainly this will define and redefine our processing and logistic and handling things. So I think for us the biggest challenge is how can we prepare ourselves, our production, in a way that our customers will not recognize that we are supplying them 20-30% recycled-based materials.
Thank you. And I just picked up a last interesting question from the tablet. So if you don't mind, I would give the floor again. So the question to you, Peter: do you plan in the future a strategic alliance with some of your current or future peer or PCR material supplier?
A very interesting question, which I would not like to disclose.
Okay. Thank you very much for being here today. I really appreciated your presence and sharing us with your thoughts, ideas, and interesting comments. Really appreciated. Having said this, I return the floor to Vanessza.
We would like to thank all our participants for their active engagement and for taking the time to be with us. Your presence and participation are highly appreciated. For any questions that were not answered during the panel discussion, we will ensure to provide answers via the email. Thank you again and see you next time.